2.5 is basic differentiation properties. In the notes that I provided my students on Canvas, you're going to find all of the properties. So you should definitely go on there and look at all of the different properties. We'll see the different properties as I do some examples. So our first example, we're going to find the derivative. In part A, they just give me f of x equals 5. So 5 is a constant. You'll see in the notes that the derivative of a constant is 0. So we already know the answer. F prime of x equals, okay, this symbol is just saying that we're taking the derivative. This is going to be the derivative. And it was a constant, so my answer is 0. In part B, we've got f of x equals x to the 6th. Okay, well, this is the power rule. So we're going to say the derivative equals, and what you do is you bring the power down in front. So you've got 6x, and then you subtract 1 from the power, so 5. And the power rule is basically going to get us through all of these examples. Okay, part C, f of x equals x to the negative 4. Okay, well, the derivative f prime of x equals, bring the negative 4 down in front, and then negative 4 minus 1 is a negative 5. Part D, f of x equals 1 over x to the 6th. Well, wait, this is not written as a variable to a power. We've got it in the denominator. So we can't quite use the power rule yet. You may have to rewrite some of your problems before you can find your answer. Okay? Well, remember, if we move this term up to the top, it just changes the sign of the exponent. So I'm going to rewrite my f of x first. It's x to the negative 6. And now I can use my power rule again. It's just like part C. So f prime of x equals, bring the negative 6 down in front, x negative 6 minus 1 is negative 7. And, you know, if you've got a multiple choice question, they may not leave the answer like this. Some textbooks don't like to leave a negative exponent in the answer, but remember, if you move it down to the bottom, it changes it to a positive. So this is the same thing as negative 6 times 1 over x to the 7th. Okay, or you could put negative 6 over x to the 7th. Same thing. Part E, I've got f of x equals x. Okay, well, let's do it with this one. We've got f prime of x equals, well, the power is 1 if there's not a power written, so bring the 1 down. Well, of course, you don't have to write it. Okay, so there's a 1 in front of the x, and then if you subtract 1 from 1, you get 0. Well, anything to the 0 power is 1. Okay, so the derivative of x is 1. Okay, in part F, we've got f of x equals the cube root of x to the 4th. Well, again, we can't use the power rule with the way that it's written, but we know how to change this so that it's written as just a power. So before I find the derivative, I'm going to rewrite my problem. Okay, I've got x. Remember that the power on the inside is the power that's in the numerator, and the index is your denominator. Well, now we can use our power rule. Okay, so f prime of x equals, bring the 4/3 in front, x, and then we have to subtract 1. Well, if you need to, if they're a little bit more complicated, write down what you're doing. You're taking 4/3 minus 1, but I need a common denominator. The denominator would be 3. So multiply 1 on top and bottom by 3. You get 3 over 3, that's 1. And then you can easily see what the answer is. So we get 1/3. Okay, and again, they may rewrite the answer so that you actually have a radical in your answer. So you could do that. 4/3. And then there was a 1 on top, so the 1 goes on the inside, but you don't need to write it. And then there was a 3 on bottom, so that's the cube root. Okay, so you can write your answer like this, or you can write your answer like this. I don't mind, but if you're on a test and you have a multiple choice question, they might write it either way, so be aware. Part G, f of x equals 4x to the 5th. Well, it's the same thing. They just put an extra number here in front, but you bring the power down in front, and if there's a number already here, you just multiply it times that number. So the derivative of this one, bring the power down, so 4 times 5, x, subtract 1 from the power, so 4, and then go ahead and simplify it, 20 x to the 4th. And once people get used to taking the derivative, they don't write out this step. They just say, okay, 5 times 4 is 20, and then subtract 1 from the power. Okay, in our last one here, they give us a whole slew of terms. Well, you just do the power rule with each of the terms. And of course, we're going to learn more rules as we get into further sections, but in this section, basically the power rule is going to get you through all of the problems. Okay, well, of course, we need to rewrite some of these problems before we can use the power rule or some of these terms. So let's rewrite the terms. I need to bring that x cubed up to the top, so this first term we can rewrite as 4/3 x to the -3 minus, I need to bring the x to the 5th to the top, so 2x to the -5 plus, and I don't really need to rewrite this one, but it's kind of nice to remember what is in front of my x squared here, because there's an 8 in the denominator, so it's actually 1/8 x squared. That's going to make it look a little nicer so that we can take the derivative. Okay, so let's go ahead and take our derivative. Well, we're going to bring the -3 down, so we've got 4/3 times -3. I'll put it over 1 so that we've got a nice fraction that we can easily multiply. X, -3 minus 1 is -4. Minus 2 times, bring the -5 down, x, subtract 1 from the power, so -6, plus 1/8 times, bring the 2 down. Again, I put it over 1 since we've got fractions here to make it look a little nicer. And then x, subtract 1 from the power, well then that's just 1, so I don't even need to write it. We can neaten it up a little bit. Let's go ahead and neaten it up so the answer's nicer. These 3's cancel, so really we just have a -4 in front of the x to the -4. -2 times -5 is 10, so we have plus 10 x to the -6, and then we've got plus, let's see, 2 goes into 8 4 times, so this reduces to 1/4 x. And you can do more rewriting if you want to. If you want to change your negative exponents to a positive exponent by bringing it down to the denominator, you can do that. but I'm going to leave it here. Okay, then in example 2, let f of x equal x to the 4th minus x cubed plus 7. The first thing they want us to do is find the derivative, just like we've been doing. Bring the 4 down, so 4x, subtract 1 from the power, cubed, minus, bring the 3 down, so 3 times 8 is 24, x, subtract 1 from the power, squared, and then that's a constant, so the derivative of a constant is 0. So we've got our derivative. In part B, find the equation of the tangent line at x equals 1. Well, this is why I did this section on finding the equation of the line. You need to remember how to find the equation of the line to find the line that's tangent. So y minus y1 equals m times x minus x1 should look familiar. Go ahead and use this formula and we'll find all of the pieces. Well, first of all, the x1 is the x that they gave you in the problem. Okay, so the x they give you in the problem is your x1. Got that covered. The y1, you're just going to plug whatever your x1 is into the original function. So we're plugging 1 right here. So we've got 1 to the 4th minus 8 times 1 to the 3rd plus 7. Okay, well that gives me 1 minus 8 plus 7. Okay, so that gives me a negative 7 plus 7, that's 0. So we get 0 for y1 in this problem. Okay, and then your slope is your derivative. You'll see in some of the notes that I put on Canvas that I gave the meaning of some of what the derivative can be, and one of the meanings was the slope of the tangent line. So your slope is going to be putting in your x1 into your derivative. And so that's why they asked us to find the derivative in this one. So we're just going to plug the 1 in for our derivative here, and that'll tell us our slope. So that'll give me 4 minus 24, which equals negative 20. Okay, so we found all the pieces we need, so finally just plug them into your formula. So we've got y minus the y1 we found was 0 equals the m we found was negative 20 times x minus my x1 is 1. And then just put it in slope-intercept form. This one's not bad because this one was 0 right here, so this is already y. And go ahead and just distribute your negative 20. So negative 20x plus 20. Okay, so make sure to look at the other examples I put in the notes and try out the homework.